So that's about it. You have any questions? I'm open.
Let me see. Let me see. We've got Jeremiah and Eric. And why don't we go to Eric? Eric, would you like to go first, sir?
No.
Oh.
I'm explaining what I can explain in the messages, and that'll be it.
Okay, I'll read it. I've been talking. I haven't read anything yet.
Oh, I'm sorry.
I'm not posing a question.
Oh, okay.
I apologize. I think probably me and
Todd,
both.
Todd has it. Todd, in my opinion, okay, it's my personal opinion. Todd is on 98.999% of the correct track.
Thank you.
In my opinion, but I don't know anything because that's what we've all been told. So I'll leave it at that. And I'm done talking.
I think you know things, Eric. I think you know a lot of things.
Honestly, I'd like to have Eric on. I mean, that guy knows so much. I would love to have you speak for an hour. I would love to pick your brain in the Q&A.
Okay, well, let's do that then. Let's get Eric as one of our speakers. And I will write him as soon as I finish apologizing to David Chester. So.
No worries. Yeah, I also figured I could provide a few comments and maybe a question at the end. So I see a little bit more detail about what you're talking about in terms of this scalar. So yeah, I know what that the gauge dependent scalar, that's usually gauge dependent, that kind of relates to longitudinal effects in certain modifications of electrodynamics. As far as I've looked into it, you could make a very solid case that Maxwell's treatise does allow for that scalar, especially when you look into the work of Heaviside shortly after.
Well,
so I just want to say that
in fact, Heaviside is the one that gauged everything out. So he's the one that screwed everything up.
Yes.
So he defined. So in order to explain the magnetic vector potential, he comes up with the magnetic field that equals the curl of that. And so then you can now arbitrarily choose your gauge. And so there's the Lorentz gauge and there's the Coulomb gauge and whatever other gauge that you want to invent for a particular problem. And those things work well for almost all of the current problems in physics and especially electrical engineering, because everything like Ampere's law, right? That test is done with copper wires, and they're identical copper wires. Okay, if you change the material in one of the wires and you make it the drift velocity higher in one of the materials, or the geometry different in one of those wires, you're not going to get that force, that Lorentz force between the wire that you normally see. You're going to have additional effects that are indeed difficult to measure, and they're not obvious. But when you do it correctly, you observe them. And Maxwell had 20 equations originally derived, and they were reduced to 4. And the magnetic field, in Richard Van Duret's opinion, my opinion, and his strong opinion, I mean, he's 100 times more intelligent than I am, but he has figured it out, I think. Of course, maybe he's wrong on some things, but he's not wrong on everything. And the point is that you have to look at the material of the conductor that you're using when you're applying Maxwell's equations, and you have to look at the geometry of that conductor versus the geometry and material of another conductor that's interplaying with that conductor in different reference frames. So you might have one in a rotational frame and one in a stationary frame. You might have two flat surfaces, passing across each other parallel or perpendicularly, and you'll get different effects, right? And so, and there's also a way to amplify the effects. And so there's these cross product and dot product terms that can be amplified with geometry. And then so you can get, more powerful effects out of that. And Richard goes into this, and so I can say this, but the scalar potential, when it's built up at a coordinate position in space, that dilates time. And when you realize that the gravitational field really is a time dilation gradient, where things accelerate in the direction of decreasing time dilation. Black holes have huge time dilation, right? And you're sucked into it. But time does not stop. So the frequency of a photon never goes to zero. So it's important to note that time. So there is an absolute frame, and there's an absolute clock. And that's what Dr. Randy Mills has figured out. And I don't care what anybody thinks about Dr. Randy Mills and brilliant light power. He is correct on pretty much everything in his book, and his power source works. It draws from potential energy in the hydrogen atom that's available. There's no perpetual motion involved. But the point is that really, in terms, let's talk about propulsion and not energy. It's mostly about time dilation. Now, I don't know that. So there is some aspect to warp speeds and warping and faster than light involved in this, but Richard is that is something that's unclear, and then also that's something that Richard handles. But so Jack has this warp theory, right? And all the power to him, because we're not going after a warp theory. We're not going after faster than light. Maybe Jack is perfectly correct. Maybe he knows how to go faster than light, and maybe we don't. Maybe we probably don't, right? So who cares though? If you can get a propulsion mechanism to give yourself a hoverboard, or to launch cargo into space, or to keep a satellite stationed in orbit, that's very useful, right? And there's that's so a lot of it has to do with time dilation, and there is a way to control the clock rate in the local environs. And so when you see these craft, you look up in the sky and you see this craft jump.
Ooh, lost audio on Eric.
Is sped up. So that quarter second that you experience is actually maybe 5 seconds for them. So they're a leisurely acceleration into that, right? And their ruler expands. And so in other words, literally their rule of measure expands. And so instead of having a 3 meter, a 1 meter stick that you hold in your hand, their 1 meter stick is 10 meters long. And so to get to the sun, just on a normalized fashion, you might have to travel 10 meters, but they only have to travel 1 meter to get to the sun. You understand? Because their ruler is expanded. You understand what I'm saying? So I think that's in part how it works. I don't know that. Maybe there is no warping, and maybe it's just a change in the rule of measure and control of the local clock. And so Jack talks about time travel and all that kind of stuff, and maybe he's right, but I don't think it's time travel. I think it's the mastery of time. So you can control the clock rate, but you can't fuck around and go back in time and forward in time and all this bullshit. And maybe I'm wrong, but I don't think that's possible. I think you can control the clock rate. And the interesting thing about controlling the clock rate is, let's say what I call them are engineered habitats, right? So you engineer a habitat where the clock rate is increased, and now you can suddenly perform more computations per second than you can outside of that environment. And that's where things get really interesting, because then you have, if you can do that, then you have the advantage, right? So if another country can do that and they can compute more per quote unquote second, you have a disbalance of power. And so these technologies have to be, if they work, they have to be accepted by this world civilization, and they can't be fought over. They have to be used for peace. Do you understand? We have to tear down the Berlin Wall along every border of every nation, if you understand what I mean. And I'm not talking about socialism. I'm talking about, we have to tear down all of these Berlin Walls and real.
Lost again.
Yeah, he's coming in. I still have a question yet for Eric before he ditches.
Yeah, go for it.
Tim, you're muted.
Eric, did we
I
lose
think
you?
he time traveled.
Jumping in now.
Tim, you're muted too. Just I seen you trying to talk there for a minute. Check your mic.
He went to another dimension or something.
Yeah, Eric, do we still have you? Or no? Are you gone? He's gone. He's gone. Tim's out. Who do we have?
They got him. All right. So I have a question for Todd. If he's here, we can roll to that.
I'm here. Can you hear me?
All right. So Todd, I had a question. One comment said that you were totally right about high magnetic polarizability also changing the impedance and help to trap xenic surface waves or surface plasmons, and these different like surfaces of those layers in the metamaterial. But how do we prevent accidental stirring of the water in your experiment too? Because you had that water sample, and do you think we should use solids to avoid accidental like stirring of the molecules in the liquid?
Well, I mean, I looked at I can't think of the guy's name now. Damn it. I looked at the equation that that governs this, and the temperature difference between 0 centigrade frozen water versus room temperature water, it's pretty much negligible. And unless you're down into the low Kelvin, it's not going to make a heck of a lot of difference. So it's the population density, that you're going to get. But you do, I mean, there's probably better materials to use than water. Probably the mu metal is a better material to use than the water, but I haven't spent the time looking into it yet because I'm just focused on doing what I started out to do.
Right. This is just a basic preliminary setup too. I want to remind the audience watching that water is used in laboratories. That's what's used in most NMR machines, is they put samples inside of water when they analyze them. So
Yeah.
I guess unless it's boiling, it's not really they're not moving around enough to make much of a difference.
Right. And this is a proof of concept. So it's it's a learning experience for myself, because I've never done this before. And 5 years ago, I never thought I would. So here I am trying to make a nuclear and magnetic resonator in my garage. We shall see how it goes.
You can always use, ultrasonics or acoustic waves to effectively vibrate or mechanically disturb that material without having to worry about it sloshing around too, if you didn't want to get, other weird or compound erroneous measurements.
Yeah. The thing with the measuring the change in the Larmor precession frequency with respect to vibration or oscillation, so I can get a calibration of how the frequency is affected with the rate of acceleration, which is the connection to gravity, right? So that's what I want to measure. And that measurement is going to be difficult because it's not going to change very much at low rates. So I actually need something that's going to make it accelerate quite quickly. And I have some piezoelectric transducers thanks to Jim Woodward, that I can use to make some really high vibration frequencies, and I have the frequency generator to do it. So
That you do. That you do.
So this is going to be an interesting couple of months to get all this together and tested and working. But you know, and then after that, I've got several of these mega drives that I made to test, and some new ideas that I have on my own. And I finally have the springs necessary to measure a change in or measure some level of thrust, hopefully. If
Did you get the same ones they talked about at Estes Park or something similar?
Yeah, the same ones, and a couple of others that are a little stiffer. But I got enough of them to make like a bed that it can rest on, so that if there's any kind of thrust at all, it'll change height.
Now you built your Mega Drive though, right? Or did Woodward send you something?
No, I built them.
Testing?
Yeah, you built.
Testing?
That's awesome.
I had a
can hear you.
buddy of mine
can
that works
hear
in
you.
the metal shop, and he did the metal work for me for a bottle of tequila.
That's
Todd,
not bad.
Okay, sorry guys, you can hear me okay now?
Yes.
Yeah, you're all good, Tim.
Okay,
I
I'm
want-
sorry. I'm sorry about that.
Machine. Your work on your machine, Todd, is just gorgeous. Those coils and everything, they're sexy, man. I wish I had built something that looked that good. Now, if it works that good, then we'll all really be impressed.
Yeah, I hope so.
Todd,
Paul,
it sounds like you're doing some good work.
thanks, Paul.
I'd like to make some other comments. I've been rather quiet about all this, especially about Smiling Jack. I have argued with him for years, and you see it in the write-up, that, hey, it's great to have a idea, a theoretical idea, but if you can't put it together, it's useless. And he's beginning to sound more like an engineer. But the question here is that, you know, I have one thought, and that is, when you have this metamaterial on it, you've got to get it in the same phase at the same time, or you might have some problems. Like you may have the wrong phase where it's gravitational in part of the spacecraft, and if it's anti-gravitational in the other part of the spacecraft. Now, either you're going to tumble around like crazy, or you're going to tear yourself apart. So there's a lot of engineering materials that have to be looked at. Now, Jack made the comment about historical sense. As far as I'm concerned, I've looked for as much information as possible about the wrecks of UFOs and the materials that were involved. And with only one exception, a piece of Russian work in a hill that was identified with Paul Potter, they talk about 3 balls. I believe in the constellation work of Potter and so on. We have 3 spheres rotating, and apparently there was 1 sphere, and it had some funny material. But the rest of the spacecraft showed nothing. I've never heard of any spacecraft wreckage that has been involved with metamaterials. So I raise questions about that rationale. I'm not saying he's wrong. I'm not saying he's right. But I'm just saying, looking at the evidence, it's tough to say that, hey, you could see something like that.
I believe there's this researcher named, it's like Elizabeth, is it Moulton Howe or something like that, who allegedly may not have had some material and gave it to put off. That's just what I've heard. I have no idea if it's true. So
Yeah,
all I'm
no,
saying is what we should do is look at this type of stuff out there to see if the evidence exists. Now, last week, I made this comment about the magnetic field. And I'm beginning to wonder right now that if you look at the Lorentz force, there's a 1/c involved. So the magnetic field may not be as strong as an electrical field because you have the 1/c term on it. So I'm beginning to wonder about those things as well as other things, but that's as far as I'm concerned. And I'd like to suggest that if anyone blew any of you guys away in terms of personalities and stuff like that, ignore it. Ignore it. He's a nice guy. I still like him, even though he is an asshole. So all I'm saying is hang in there, and maybe you could find something goodness out of all this. And with that, I'm going to eat dinner. Thank you.
Right, well, hey,
Well, I mean, Paul, is there a spacecraft in the possession of the United States?
I would argue that based upon
I mean,
what
yes,
I know,
yes or no?
not for me. No, I didn't do it work-wise. If that's what you're hinting at, well, I'm saying
I'm not hinting at anything. I mean,
okay, as a private citizen, I believe in Roswell. As a private citizen, reading the open literature about the Russians, they've shot a few of them down. Okay.
All right. So who's the best person to ask in the United States?
The other question that you have to be concerned with.
I can reply to that.
Okay.
I'd like to say something here. I was contacted by a very credible witness who is afraid to go public. He's seen this many years ago, he and another eyewitness. He testified to me in a letter, proved his credentials. He's an engineer, like many of you guys, who testified that he was very close, he and a friend in the New Mexico desert, to a UFO. Apparently was as close to it as you could touch it. And he saw written on the UFO, U.S. Air Force experimental. I believe the guy.
Okay, that's
I believe
fine.
the guy.
That's
and
fine.
He was very credible.
But let me mention another factor here, and some people that were hinting at it, that can you destroy a UFO? And it seems like whenever people are being abducted, if they're using a flashlight at night, these things start moving around. And if you recall, there was a shuttle picture film of an object moving along, and then all of a sudden it moves away, and then this big spot comes through it. So apparently these UFO guys are concerned with lasers. And that might be the way to look
Sheila
at it.
Widnall, the Secretary of the Air Force, Sheila Widnall, who's also an MIT alum, she sent me pictures of a telescope image, a few of them, where, you know, when the Challenger blew up, that there was there was essentially some type of beam that blew it up.
Yeah.
And she did this while she was a Secretary of the Air Force, and she did it because we both went to MIT. And I still have those pictures, but they're not very convincing. But I mean, why would she send me that, right? So my question is,
there's another picture, another film where it's going on against a UFO with a ICBM.
Of course, that was on NBC News, I think.
Somewhere. So, you know, how real are these things? I said, well, gee, you know, why not?
All right. So who do we ask in the United States if there's a spacecraft in the possession of Department of Energy? Who do we ask?
I got involved with the Challenger details or about it getting destroyed. Okay. And the question was the problem occurring after 73 seconds, or was it happening right away? And guess what? With all of the shuttle pictures for the Challenger, NASA said, we didn't turn on their cameras. We did not.
No, I'm sorry. Not the one that blew up going up, the one that blew up coming in.
No, I'm sorry. The one that went up. The one that went up.
No, I'm talking about the one that blew up on its way down.
Discovery.
Oh, shit.
No.
Discovery, yes, that's it. The one that blew up on its way down, Sheila Widnall sent me photographs of that getting hit by something, and that's the one that's of interest. Not the one, not Challenger in 80 or 84 or 88, whatever that was. It was after that.
Having worked on the shuttle, being an aerodynamicist, and doing all sorts of great things with lasers, I believe that the wing leading edge of that thing was broken with ice, just like it burned out, because it starts talking about the wing disappearing and then the wheel getting hot and the way everything went. I believe that. Right. But to answer your question, the issue is that you have to look for the truth amongst yourself. You can't depend upon governments because they have their own agendas, okay? And you will never know those agendas. For example, I'm going to be giving a presentation about UFOs, about how it started. And I'm suggesting that in 1947, Einstein sat down with Oppenheimer and they laid out the rules. And they kept those rules going for over 70 years. And they identified, just like Jack said, we can't do a damn thing about it. We can't chase them. Well, you know, like I said, the Russians have been engaging them with Su-27s and other craft and stuff like this. But that's the way it goes. So you have to look for it yourself. You've got to look at some enigmatic material, and half of what you see you can throw away, but the other half might be, you know, pure gold.
No, but I mean, I don't want to. That's not a productive. I wanted to ask somebody who knows the answer, right?
What is productive?
Oh,
And
Well,
what
so
do you
does
do if they get
so
the
if we
answer?
have
It
a
sounds like he doesn't
spacecraft
know.
So if we have a space,
Eric, let me respond.
if the Department of Energy has a spacecraft in its possession, then other people should be allowed to inspect it so that we can all help understand the propulsion mechanism.
Well,
so who do we ask? So
You
who knows?
heard the
Eric-
old argument that if this gets
We should
out,
do a whole separate
impact
conference
your
on this
lives.
because I have a lot that I'd like to present. I think we should let Paul present, and I'd like to present my whole research because I have a ton of research that I've been doing into Roswell. I'm going to be talking
Okay. Well,
and debating on that next week on with Cal Korff and Kevin Randall and some of the with skeptics and other researchers next week and stuff. So let's save all this for like another separate conference and get back.
yeah, let's
Let me
do
say
that. So,
goodbye.
Jeremy, will you email me about this? Just email me, and we'll
I
get it
want
on
to
the
set
books.
that up with Paul because I think it would go right in tune with that, and it's separate from you know, we should definitely set that up because this is something that we should hash out within this group and kind of, you know, filter through for the actionable intelligence, like Eric was saying.
Okay. Bye all.
Thank you again, sir.
Paul,
Definitely. Thank you, Paul.
about the metamaterial and having gravity in the front of the ship and anti-gravity in the back of the ship. Oh well. He didn't hear me.
Oh, okay.
But
Okay. Well, Todd, thank you. Let me see. So I'm going to try and organize this back up. I'm going to mute. Let me see. I'll mute Mark. So does anybody who has questions next for Todd? I guess that would be the.
I still had some comments and questions. To kind of bridge the
go ahead,
gap.
David. I'm sorry.
Oh, that's fine. So I just wanted to say that the scalar field that is going in that Lorentz gauge thing, I know exactly what's going on, and this is kind of a controversial topic. And the main reason why academia doesn't accept this is because it pokes a hole to the entire idea of gauge invariance, which is an important foundational concept for everything that's going on here. But I don't think the solution is to say that we should throw away gauge invariance, which I've done some work on this and I haven't published on it because it's very subtle and it takes a while to figure out. But the metric affine gravity theory is the gravitational theory that gauges how you have rulers and metrics and length and stuff. So, you know, so I heard some comments before and people say, oh, well, that's not, you know, maybe gravity actually is this. That is exactly what this metric affine gravity framework is. And within that, you can reconcile some ideas such as Tesla or others back in the day who would have preferred variable speed of light models rather than curvature. And that might be an interesting perspective to take. But I mean, in terms of convincing academia, a lot of work is needed done to go into the complicated math and then make it simpler to see if we can get back to these simple ideas that are kind of being talked about, which is kind of why I think a lot of the heavy side gravity people like it because it's so simple. But so, I mean, I think you're on the right track, Todd, in terms of focusing on that potential. But then at the same time, I wouldn't just stop and say, well, like we fully understand gravity from that perspective. So I think there in time, there can be this story that will come out where the way we think about gravity kind of unifies the ideas of Tesla and Einstein in a more friendly way, because Tesla was his whole point was saying like space-time is not a thing. It doesn't have properties, right? It's like we're measuring these events, but there's nothing there. The space-time, he was saying there's this ether, this material, and really that's what all of the stuff that I was talking about before is getting back to. So it actually is in that gravitational framework of general relativity, if you refer to it as the most general theory of relativity, because that's what it is. But it's just taking time for quantum gravity people to realize that. And so once all of that occurs, there should be simplified theories that come out that might be helpful. So yeah, as you're doing this research, don't feel like you're completely alone, or don't think you're as radical as you might think you are, because there is a chance that, you know, conventional academia could reconcile all of this.
I appreciate that. I just wanted to say that like I've been working on this for over 30 years. And so I'm 59 and a half, and I've been doing this for a long time, since I started dreaming about this when I read my first book on Einstein when I was 17. So it's a long time coming. And I've tried to get published. I've had several papers published a bunch of them in an old journal called Physics Essays, because that was the only place that would publish me, because I'm not associated with any research organization, or, I mean, I've got a Bachelor of Science from UC San Diego, but I'm not affiliated with them, so they won't publish my work. So I decided to bypass all that and go straight to, what do I need to make it work? And then once I have something that works, then maybe people will notice. But so that's where I'm at. One thing I'd like to mention though, Jack wouldn't let me finish, because his cosine theta idea is wrong, and I can explain why. And the reason it's wrong is, like, in my model, and as I was saying, gravity is a loss of power. So time dilation and length contraction are, the matter itself is losing power because it's not being excited to those energy levels anymore. And so it collapses in on itself and free falls. Anti-gravity is the opposite. You're exciting the matter. And exciting the matter, you're doing work on it, just like lifting it to go uphill, lifting it up. You're doing work on the matter, which inflates it. The energy, the matter gets excited, it inflates in size. As the matter volume increases, the energy goes up slower. So the energy density is going down as it inflates. So as like I lift this battery up, its energy density went down. And that's the nature of negative energy density in warp drive and in this equation, is that in a variable speed of light model, the speed of light here is slower than the speed of light here. Same thing. It's the same procedure. It's the same process. And so you don't need a negative energy density that's below zero. You need a negative energy density added to the positive energy density of matter, which makes it less dense.
It's all about how you calibrate everything you're working with. So it could be possible that different calibrations actually are agreeing in complicated ways. So, you know, that's why I like to stick to general relativity, just because there's so much and stuff beyond that, just because there's so much experimental success. I mean, cosmology is a mess too, but that is being figured out with conformal gravity. And so, I mean, in terms of other theories of gravity, like, I'm not trying to shut them down or anything like that, but if you're going to use intuition from that, then we need to first make sure that that theory is, you know, comparably successful to, you know, can we get the perihelion of Mercury? Can we get all these different things? So, yeah, just
you know,
comments,
and if I can jump in, David, I really like that. You know, when you just expressed the framework of using a model, right? And I mean, Todd may be using a slightly different model. I've heard, you know, because I've done a lot of interviews in this area, I've heard probably hundreds of different models. But I think it's always important to remember that we are working within these frameworks, right? Now, whether that's custom built or like David is working within general relativity, or there's QM, you know, but and each of these models has limitations, and, you know, they've got their own structure to them, you know? And so I think that's one of the things that I've seen is a lot of people run into trouble because they're kind of like, well, this is how it is, this is how it isn't. But then that always kind of relates to the model that you're working with too, right? So.
I just want to say that the back in the late 1990s, Hal Puthoff and I both developed a concurrent model based on, we called it the polarizable vacuum model. He calls it the polarizable vacuum representation of general relativity. And in that original paper, he showed how it agrees with the perihelion of Mercury and time dilation and all the experiments of general relativity that rely on basically the Schwarzschild solution. And I came up with a similar theory. And then I took it one step further because I took it down into quantum mechanics and damping and QED, and showed that when you add a relative damping factor to the equations of QED, you get the polarizable vacuum model exactly. And it's already been shown to match general relativity in all the observable experiments. And we did this back in the late 90s and early 2000s. And Jack now, puts a refractive index in Einstein's equations and, claims he thought of it. But Hal and I were doing this with the refractive index since 1998. And we had the polarization and the magnetization in the TUV tensor, decades ago. And I wrote a paper in 2003, warp drive propulsion and Maxwell's equations. And on that paper, I, hypothesized that the effect you want lies in the hull of the ship, not in the space around it. And so all of this stuff has been around, basically about 18 years ahead of where Jack is on this. And I know what's going on. And Tim, in regards to what you just said, I agree. Everybody's got a slightly different model, but at times when people are presenting their model, I can see where the differences are and I can tell which one is right and which one is wrong. And sometimes I know it well enough that I can tell you that. And
And I won't disagree with that. Although the thing that I do like about models is that I think it helps prevent fist fights, right? So that's always a bright spot. It's much easier to agree to disagree, I think, that way. So, and I am not disagreeing with what you're saying.
I'm a natural-born educator, so I like to teach people what's and unfortunately, I like to correct errors and fix things, and a lot of people don't appreciate it. But I appreciate that David does and Eric did, and I know you guys do. So I'm I'm happy to be working on this stuff, and I'm happy to be part of this group.
Yeah, well, and thank you for presenting. So if it's okay, let's jump over to Mark next, Todd, if you're all set.
Yeah, I'm done.
Okay, thank you, sir. Thank you again.
Thank you.